Hello everyone, welcome back, and today I want us to learn floating static root and this is our topology. First, let's define what is a floating static root and how it does. A floating static root is a root used to provide a backup route in case the primary route fails. This backup route or floating static route has higher administrative distance than the primary route, making it less preferred under normal circumstances. However, if the primary route becomes unavailable, the floating route is used as a backup. So, point number 3 here, we are being told that the administrative distance is a value assigned to routing protocols indicating their trustworthiness or reliability. The lower value, the preferred route. So, administrative distance is a value assigned to the routing protocol to indicate trustworthiness or reliability. And each and every protocol has its own administrative distance. Like for directly connected routing, we have a D of 0. It means it's more or the most preferred connectivity between routers. And we have the second one is static route. It has an ID of 1. We have the static route, the floating static routes fall under the static routes, but we will increase the ID for the backup because the ID of 1, it means trustworthy, it's more trustworthy. But if we assign the ID of 10 instead of 1, it means it will be less trustworthy than the main static route. That's why for the floating route we can increase the AD from 1 to 2 all the way up to 89. So we have this one, internal EGRP, we have a D of 90, OSPF, we have a D of 110, we have RIP, we have external EGRP, and unknown. So for the floating route, it's under static route category, but as a backup route we have to increase the AD from 1 maybe to 2 onwards. So concept number 1, floating static routes are configured with higher AD or administrative distance than the primary route, ensuring they are only used when the primary routes fail. So as we have said, the primary route has a D of 1, but for the static route, the floating static route, we can add the D of 2 all the way. That's why you have been told here the static routes are configured with higher administrative distance than the primary routes, ensuring that they are only used when the primary route failed. By assigning a higher AD to the static route, it becomes less preferred than the dynamic routing protocol or directly connected routes. So when you add higher AD for the static route, it becomes the backup for the primary, and also it's the less preferred than the dynamic. It depends on the dynamic routing. We have these dynamic routes. So if you add for the floating route, if you add the AD of let's say 91, it means the floating static route will be less preferred than the internal EGRP. So the packets will use this routing than the floating route, which has more AD than 90. But for our configuration, apart from the primary route, which is by default 1, we will add floating with the administrative distance of 10, and we'll see after when we do configuration. So this number 2 configuration. To configure a floating static route on a Cisco router, use the following commands. This is our topology. We have client PCA and PCB. These are the networks for the direct connected, 192.168.1, and here we have .2. And here we have a bunch of networks with the routers. So from PCA to reach PCB, we can have 2 routes. From PCA, the packet from PCA can come to router 1, go to router 2, router 3, all the way to PCB, and the reply can use the same. The reply can use the same, or else the packets can move from PCA. Let me choose a different color. The packet from PCA can come to PC1, can come to router 1, then they can choose router 4, router 3, all the way to PC, and they can use the same reply. They can use the same route or use the different routes. But as an engineer, maybe you know the capacity of routers. Maybe this router number 2, it has more processing power, it has more backup plan, the power backup plan than router 4. So you would like all the packets to use these routes. You can configure all the packets to use, all the packets sent to PCB from router 1 to use router 2. But we have maybe a failure for the router, or we have the connectivity failure. Automatically you can configure the packets to use this route. So that's why we are here now to configure the floating static route. Now let's go to the syntax configuration. We have our syntax. We have IP route, destination network, subnet mask, next hop address, and administrative distance. So our first configuration is on router 1. On router 1, we have this configuration: IP route 192.168.2, 192.168.2.0. Destination is a destination network, and this subnet mask, this one. The next hop is 192.168.10.2. This means that from router 1, any device connected to router 1, like PCA, to access this network, or any device within this network, for example router B, from router 1 to reach this network, we must pass through 192.168.10.2, this route. So it means from PCA to reach PCB, or for the packets from PCA to reach PCB, it says that we have to use this route, and we have as a primary route, as a primary static route, by default we have a D of 1. So this is our first route, the primary route. Let's go to the floating static or the backup route, this one. It says that IP route to reach this network, from router 1, we must pass 192.168.20.4, this one, .20.4. It says that for the backup from PCA to go to PCB, from router 1, we must pass through router 4, and with administrative distance of 10. So administrative distance of 10 means it's less preferred than the primary route with the ID of 1. This is how we interpret this command. So it means that if in case we have a failure, connectivity failure or the router 2 failure, then automatically the packets will move from router 1. We use this backup with this command. Let's go to router 3. This one, router 3. It says, router 3 says IP route for the primary route, IP route 192.168.1.0 to reach this network. 255.255.55.0, this is a subnet mask. Our primary next hop is 192.168.30.2. This one, it says that the primary route, when we want to access this network, we have to use this route. There are some reasons why engineer uses this route. As we have said, maybe the higher processing power of this router or more power backup plans. That's why the engineer wanted the packets fast to use this route. And also maybe we can have redundant connectivity known as ether channel. Maybe this route engineer can configure ether channel and force all the packets to use router 4. Those are some of the reasons. For the backup route or floating route 192.168.1 to reach this network as a backup route, we can use 192.168.40.4. This one, .40.4 with a D of 10. So all the way from here, PCB, for the primary route, we are forced to use this route. And for the backup, we are forced to use this route in case we have failure. Router number 2, this router number 2, there's no need for us to configure the backup route. There's no need for us to configure the administrative distance because this router has the intelligence of this configuration to know which route the packets can use as a primary route or as a secondary route. So for router 4 and router 2, we can just configure the static route. So router 2, it says that to reach 192.168.1 from router 2 to reach this network, we can use 192.168.10.1. This one, we can use this route as our next hop. It said that from router 2 to reach this network, our next hop will be 192.168.10.1. And also it says that to reach 192.168.2 to reach this network, we can use 192.168.30.3. We can use this route. From router 4 configuration to reach 192.168.1.0, we can pass via 192.168.20.1. From here, to reach this network, we can use this route 192.168.20.1. And for router 4 IP route to reach this network, we can use 192.168.40.3. This from R4, we can use this one. Those are the only configurations we have for the floating static routes. So let's go to Packet Tracer and do the configuration. So this is our network diagram or topology. Now we want us to configure the static route or the floating static route. And PCA we have 192.168.1.10 and PCB 192.168.2.10. So from router 1 we enable, and before we configure, let's do a show command to see any configuration. Show run. You can see here we have interface F0/0. This one, we have the IP address assigned, and this IP address of F0/1, and this IP address of Ethernet 0/1/0. This one we have already configured, and I've also configured a dynamic routing HRP. So it means that I've configured HRP for each. I've configured the interfaces. I've assigned an IP address for each and every interface, and I've configured HRP. And we have seen that HRP has ID administrative distance. Internal HRP has administrative distance of 90. So it means we can communicate. You can ping from PCA to PCB. We can ping. Let's try to ping. Ping 192.168.2.10. Yes, we can ping. From PCA we can ping with the courtesy of HRP. We have configured dynamic routing. But after configuring a static route, the HRP routing will be obsolete, will no longer be used because of administrative distance. It has administrative distance of 90, and the static route has a default ID of 1, and the floating will be having an ID of 10. So HRP routing will be null and void after we configure the static routing. But currently we can ping. We can also try with the simulator from here. From here we can ping. You can see how packets move. They can choose whichever path because we have not configured the backup plan. They can use whichever path. Now from PCA to router 1, as you can see, it goes to router 2. It goes to router 3. It goes to switch now to network 192.168.2. The packet from PCA has reached PCB, and we have a response. We have a reply that okay, I've received your packet. I'm working on it. There's our communication now. As you can see here. Now first it has used this route to router 2, and the second, the reply it uses the R4. Because we have not configured the static the floating, the backup routing. That's why they can use whichever the path. Now let's go to our configuration, the static routing and the float static route. From router 1, config terminal. I can configure, or I can just come here and copy this router 1. What does it say? It says from router 1 to reach this network, we have to pass through this link, this route, and this will be the backup. Enter. We can actually copy instead of configuring each and every router. So it's the same route. It's the same network, sorry, but with a different route. Then this is the backup because we have ID of 10. Here we can add ID of 1, but we can leave it because by default static route has an ID of 1. Now we have already configured. Run start. We can do a show IP route. Now we have a static route. This of ID of 1. We have ID of 1. This is a static route, the most preferred now. After connected, the most preferred is the static route. And this is the route 192.168.10.2. This is the most preferred. As you can see now, these are dynamic routing with the ID of 90 HRP. They are less preferred because, as you can see, they are down because of this ID. When we first do the show IP route, you could see this route being here before configuring the static route. But after we configure the static route, this dynamic routing now becomes the null and void, or the absolute. Let's go to router 3. Sorry, not PC3, router 3. Now, let's do the show IP route. Okay. We can see HRP is most preferred with the ID of 90. To reach 192.168.1, reach here from R3, we can pass via 192.168.30 or .40, any you can choose. But now let's configure the floating static route and see. Then the static route will be here. Now from router 3, you can just copy, enter, done. Can exit. Now let's do the show on the same command, IP route. So before we had this dynamic routing HRP as the most preferred, but after configuring the static route, you can see now the static route is most preferred with the D of 1. So the dynamic route will become the absolute null and void after we configure the static route because of the AD, administrative distance. Let's copy, run, start. We are good. Now let's go to router 3. Enable show run. Have all the configurations. We have HRP protocol configured. Now let's configure static route 2. Show IP. As you can see now, we have the static as the most preferred. Copy, run, start. Router 2, we are good. Now let's go to router number 4. Show IP route. We have this HRP dynamic routing as the main. Show IP int brief. We have configured these interfaces, so we are good. They're up. Now we can do configuration for the floating static route. Router 4. Enter. Do show. We can use a do show on this global configuration mode. You can just do show IP route. Now we have the static as the main. Now do copy, run, start. Okay, we have saved all our configurations. Now let's try to ping again. And let's go to simulation. Okay, let's start. The packet from PCA to the switch, SMP used, and to router 1, as you can see. As a primary, it goes to router 2. This is the primary route. Then router 3. Then goes to this network. So we have seen that. Let's check the reply. Yes, it's using the same route. Before, when we were on the HRP, it could use this route, but the reply could come this way. But now we are forced to use this route for when it sends data and when there's a reply. Now let's share this router 2 and check how the packets will move from router 2. Let me shut this. Let me power off. Router 2. Now let's reset and ping again. Okay. Let's run the simulation and see how the buckets move after this router is paired off. As you can see now, they have chosen the secondary route or the floating static route. As this is the backup route. So immediately after this route is down, automatically the packets have been changed. The route from this router, via router 2 now, it's via router 4. And now let's go to command line interface and see the routing base. Show IP route. Now you can see now we have the static with the ID of 10. It means this is the backup, because the primary route had an ID of 1. Now let's go to router 4. Now let's go to router 3 and check show IP route. You can see we have before we had this route with the ID of 1 through router 2, but now we have a ID of 10 through router 4 via this next hop .4. So immediately when this route is down, immediately everything change. The routing table change. Instead of this route, they change to the secondary route or the backup route or the floating static route. Now this is how we do configure the floating route. Just we play with the administrative distance and that's it. Please, if you have any comment, any compliment, any question, drop it down on our comment section below and we will respond as soon as possible. Thank you.